Right, welcome back. Um, we are still continuing with our smart home temperature sensor application. So from our previous tutorial, we managed to set up the basic UI components of our application. So if you recall what we did, we had a background which we set up, and then our top menu, we have our menu button here, and then we had title, and we had a bottom menu which had our navigation buttons and a power button. So let me just run this so that we can see where we left off. So this is what we did the previous time. I have made some slight changes though, but what I only did was to broaden this temperature reading, and I also changed the power button icon. If you notice that, it just to improve the look and feel of our application. It's nothing much. So what we're going to be doing in this section, we are going to create a gauge, a temperature gauge, which is going to visualize how the temperature that is being sensed by our sensor is. So we are going to create a component which is going to be right here in the middle. Yeah, so the way we are going to do this, we are not going to do this specifically in QML. I do not know whether you have dealt much with QML, but the thing is, we come to a certain point where we want to create custom components, which will be difficult to create in QML alone. We know that QML is a very powerful language in terms of UI development. It's we can develop quite good UI components using the basic the rectangle, like we did with the navigation buttons here. So the other way we can do it, we can use a canvas to draw out some complex components if we want to. But in terms of performance, using the canvas, it has performance issues. So if you want to create high performing custom components to use in QML, we can do that from the C++ side. So we can paint a component from the C++ side. So that is what we're going to do. So the way that we're going to do it is by creating a class and inheriting from QQuickPaintedItem. That is going to be our base class. So what we're going to do now is to go to here, our sources, and add a new class. We are going to call this class temperature gauge, right? So our base class is going to be a QQuickPaintedItem. This one right here. Should include the QOmlet macro. Next, finish. Alright, so the following files already exist in the folder. Alright, I had what happened is I had created these files before. That's why you're seeing this, but we're going to override them. This something happened with my power, so I had to re-record this, but it's nothing. So we have to say okay, and we can reload it. So we can put them here. So we're going to do temperature gauge, temperature the CPP file. Alright, save and wait for them to appear here. So now we have our temperature gauge class. So we can add a parent here, QQuickItem parent equals to now window. Alright, so you can press Alt Enter to Alt Enter. Okay, it seems it's not picking up that shortcut, but what we want to do is just to apply this to our CPP file. So you can go to the CPP and alright, it's already there, okay, that's fine. Alright, that's why it wasn't picking up, but that's okay. If you do not have this, if you press the Alt Enter, the shortcut which allows AO to add signature changes to the CPP file. But anyways, what we need to do now, we have our temperature gauge class. So this QQuickPaintedItem, it has a function that we need to override. So the paint is called the paint function. So if you right click here and go to refactor and insert visual functions, so if you go down here, QQuickPaintedItem, it has a paint, this paint function there. So you're going to override this in this function. That's where we are going to paint our component. But before we start with the painting, let's think about this gauge for a second. So what we need is eventually this temperature gauge is going to be connected or linked to a temperature sensor. So we are not going to have a physical sensor though in this part, but I'm just demonstrating how the concept works. So we are going to simulate the sensor readings, but the general idea behind this is we have a sensor which is going to be reading the temperature maybe in a room. So when the temperature reading comes, so we are going to get the temperature, and that temperature is going to be indicated here by the gauge. So this gauge should know about the temperature reading. So we need that information here. So private, for demonstration purposes, I'm going to assume that the temperature reading is only going to be in integral values. So we're going to have a maximum, max temperature. So the maximum temperature and minimum temperature in current. So this information is going to be provided by our sensor, but we're going to use this information to display the current temperature in our temperature gauge. So for this, let me just split this side by side and open the temperature gauge CPP file here. So we're going to give this and some default values so that we can visualize it as we work through the temperature gauge. So here I'm going to give this quick item, quick item go there. Let's see what this QQuick is not a direct or virtual. Alright, so here we need a QQuickPaintedItem. QQuickPaintedItem. So now that we have that, we need to initially to give default values for our members here. So max temp maximum temperature, so let's maximum temperature that our sensor can have is 50 degrees, and minimum temperature is 0.4. Let's have a current temperature reading of 8. Alright, so these are our default values. Remember, we do not have our sensor yet here, so for visualization purposes, as you are working through this temperature gauge, I have put in those default values. Alright, so now that we are done with that, what we now need is to start implementing our paintings. So you can definition. Alright, so what I did there is that shortcut I was telling you about. You can just press out enter, it pops up that context menu, and you can pick a definition to simply be just a shortcut, or you can just write this by hand. Alright, so now that we have our paint method here, we now need to start painting. So our temperature gauge is going to have a track. So in this track, that's where we are going to be visualizing our reading. So when the temperature increases, the value of the temperature or the visualization of the temperature will be going up that track or going down depending on the temperature reading. So what we need to include QPainter. We also need to include QPen and QBrush. QBrush. Okay, so the other input we just include them as we go. So let's start by defining our bounding rake. So what I just want to do is to create the rectangle, the bounding rake, rectangle bounding, the bounding rectangle. I'm going to call this bounding rectangle. So this bounding rectangle, bounding equals to bounding rake dot to rake. So this bounding rectangle is going to be the boundary of our component. So this QQuickPaintedItem provides us with this an API to access those bounds. So we can access them via this method, this bounding rake method. So what I'm just doing here is just to create a QRect object here. So now that we have our bounds, we are going to be using this rectangle to define our drawings. That's where, from this rectangle, that's where we are going to get the coordinates and the dimensions that we are going to be using. So first thing that we need to set up, let's set up the color. We are going to be using gradients, linear gradients for the track and the reading. So let's include here, I should include a few linear gradients, right? So we are going to have a Q linear gradient, right? So we are going to have a track gradient. Let's call this track gradient. So this track gradient, it's going to be diagonal. It's going to be to start from the top left corner and run down to the bottom right corner. So you can open the documentation. So if you press F1, you can see in the documentation here, we want to see what the constructor of the Q linear gradient needs. So we have these two constructors, so you can specify the x coordinates for where you want the gradient to start from and end. So this x coordinates, so we want to start from the top left. So our top left is going to be, we're going to get it from that rectangle x, right? And our y is going to be bounding rectangle dot y, right? And our bottom right coordinate, so if we are you're just going to use the width and the height. Bounding rectangle dot width, bounding rectangle dot height. So these are going to give us the coordinate for the right corner, right? I understand you get the logic here. So just visualize here. Let's say we have this bounding rectangle. You see this this highlight here, this bounding box. So just imagine this is our bounding rectangle, and we want this, the coordinates for this point and the coordinates for this. So these coordinates, we are saying bounding rectangle dot x and bounding rectangle dot y is this one. For this one, we have bounding rectangle dot width, it's going to give us the x coordinate for this, and bounding rectangle dot height, it's going to give us the y coordinate for this. Okay, that's fine. So we can close this and go back here. So we need to specify the colors for this gradient. So go check gradient, set color. There is a method called set color at position 0. So this is going to be the top corner, top position. So here we're going to specify a color, Q color. From string, we're going to use a x code here from string. And also we have a track gradient to set color at position 1. We are going to have a Q color from string, which we're gonna need the x code right here. So the colors for our track gradient, if we go to our colors QML, those colors, if you remember the colors we specified in the first video, we had our primary color 1, primary color 2, and primary color 3. Remember, these colors, they are increasing in darkness. Here this is lighter, this is a little bit darker, and this one is darkest. So for the track, we need this one, this lightest one is going to be at the top. So copy this and this is going to be at position 0, and this medium one is going to be at the bottom. All right, so this is our gradient for the leg. Then for the read, we're going to have a reading gradient. Here gradient, we call this the reading gradient. Don't worry, you're going to see how all this is going to fit together. All right, so this gradient now, this reading gradient is not going to be diagonal like the track rectangle. It's going to be vertical. All right, so in order to do that, we need the x coordinate to be bounding rectangle dot width divided by 4, right? And the y coordinate is going to be bounding rectangle dot y. I think you understand why I am doing this, because we need this gradient to be right in the middle, to start from the top to the bottom, right? Okay, so and for the bottom coordinates, we can do the same. The x coordinate is going to be bounding rectangle with divided by 2, and for the y is going to be bounding rectangle dot height, right? All right, so we have this gradient. So let's set the colors. Reading gradient, let's set color 8. So at position 0, we're going to have a color from string. We're going to put the x here. Also reading gradient dot set color 8 position 1, Q color from string. We're going to have our x right there. So if we go to our colors, we have these two colors. We have this and we have this. So this is going to be the bottom color and this one is going to be the top. Alright, so we're going to copy this, Control C, Control V, we copy this bottom one, Control C, and paste it there. Alright, so we are done with our colors here. So we need to create the brushes we are going to use to paint. So we are going to have a track brush. So our track brush is going to use the track gradient. You're seeing the fence, and the Q brush for our reading brush is going to use the reading gradient, right? Okay. So now we are done with our colors. All right. So what we now need is we have some global setups. So these global settings, in fact, they're going to apply for the duration of our painting here. So we're going to set painter, we're going to set the anti-aliasing to improve the crispness of our painting. So we use set render int one and QPainter anti-aliasing, set it to true. Alright, and also what we're going to do is we're going to set the pen to no pen, because we do not want to paint the borders of of the rectangles we are going to draw here. So painter, set pen, blue pen, QP, no pen, right? Okay, so we are done with this property. So other thing is this view is going to be rounded. Okay, let me just start by drawing our track so that we can just visualize as we work through this this painting. So let's do the track here. So our track is going to be painter, draw, and we're going to draw a rectangle. This rect is going to be boundary a rectangle. Okay, so the track is going to be the size of our bounding rectangle. All right, so now that we have this drawn, let's set the brush for the set brush so that it can be seen on the screen. We set the brush to shake brush. Okay, so now that this is done, this should draw our track. All right, so let's visualize how it looks at the moment. All right, so remember what we need is to use this in QML, but what we've done here, we've just created the component in C++. There is no linkage to QML yet. So what we need to do is to export this to the QML engine like we did here. All right, so first we need to include let's include temperature gauge, right? So here we register this QML, register singleton type, not singleton type, register type. So this type is called temperature gauge, right? All right, so here we give the module that we want to import. Let's call it gauges, right? And let's give this version 1.0, and the component name is temperature gauge, right? All right, so now we're done. Now we have exported our component to QML. So now we have to go to our view and import the module gauges, right? We have imported it. Now what we need to do is just to use our component. So we have our main layout, right? We have our title, we have our temperature reading, then we have our spacer here. So what we need is temperature gauge right here. So go here, temperature gauge, right? Let's give it an ID, temperature gauge, right? So this spacer is going to push our temperature gauge to the bottom. We don't need that, we need it to be centered, so we can create another spacer here so that it is centered here, so we can call this spacer 2. All right, so our temperature gauge is here, but it doesn't have the width and the height, so we need to specify the width and the height. Let's just give it a width of 220 and a height of, say, let's say 300, Let's run this and see how it appears. By the way, we also need to center this. So remember, we're in a layout, so use this appears property layout.alignment, right? Q3 align horizontal center, center, right? So if we run this, let's just see how the gauge appears. It's building. All right, so this is how the gauge appears, but the width is too much, so we're going to reduce the width. Let's have 110, right? Let's run and see how the track is appearing. Okay, so now that's better, but now we need this to be rounded. We need this to be rounded, right? So we're going to do that. Let's go back to our paint method right here. So the way we're going to do this, we're going to set clipping. So we're going to set clipping before we draw the track. So here I'm going to say clipping right here. That's where we're going to do the clipping. So what we need is we need to include QPaint. It's called QPaint path right here. This is what we need. All right. So here get the path, QPaint our path, right? Path would add right. You're going to create a regular, not red but rounded track, which a rounded track. So this is going to create the clipping bounds. So it's going to be a rounded clipping that we're going to do. Okay, you see it in just a second. So it's going to be the size of but it's going to have a radius of 15, right? Like that. Alright, so we now need to set the clipping to paint a set clip path and specify that path. Alright, now that we set the clipping, let's run and see whether it is now clipped our gauge. Now you see, so this is how our gauge now looks. So we are now done with the track. So this is the track. So what's going to happen is, as the temperature will be increasing and decreasing, so it will be visualized by the reading that is going to be in here. That's what we're going to do now next. So now that we are done with what is that, like we need to draw the reading. So what we're going to need is we need the fraction to obtain the fraction of the track that is going to be allotted to the reading. So what I mean is, we have a current reading, right, that's coming from the sensor. Let's say it's 30. So by default we've set it to 30 right here. This is the current reading. So at 30, what does it mean to our view? At what location in our path does 30 represent? So that is the fraction that we need. Let me just copy this the reading. So the reading visualization, didn't find a better name right here, but this will work for now. So what we need now, let's say int, so the reading the reading height fraction. Okay, so this is the fraction of the height of our track that we need to calculate. So this, in fact, not the fraction here. So this is the reading height, So the fraction we are going to need, remember, we are going to say current reading out of mark temperature rate multiplied by the height, the bounding rectangle dot height. So this is going to give us the reading height. So this is the fraction that I was talking about. So this is a fraction of the reading height, of the bounding rectangle height, right? So and an issue that might happen here, we need to change this representation here so that we cater for a case where this it gets converted, because remember we're dealing with integers, so we need to move things around here a bit. So we need to first multiply m current reading times this divided by the maximum temperature, so that we do not have to be fooled by the conversions which are going to be happening here. Okay, so what we need is, let's just that effect. I just needed to understand where the height is coming from. So we're going to first multiply the current reading times the rectangle, then the white, and then divide by the max temperature. Okay, so now that this is done, remember our coordinate system, it's starting from the top. So if I run this, let me show you what I mean. Okay, so our coordinate system is starting from here. This is 0, 0, and x coordinates are increasing this way, and y coordinates are increasing down here. So what we've done is, for a temperature reading, let's say of 25 right here, we have found the height that 25 degrees represents, right? So 25 out of the 50, the maximum, so it's going to be the half, right? 25 is half, so it's going to be here. But imagine if it was let's say 10, so 10 is going to be somewhere here, right? But we are not drawing our reading starting from here. We need to invert it so that it starts from below. So our 10 should be here and it increases this way. So the way we're going to do that is we are going to invert this reading, right? So let's say inverted height. So it's going to be rectangle dot height minus reading height. Okay, so this is now giving us the correct height coordinate, the y coordinate. In fact, for let's just use QQuick here, right? For our current reading, right? Okay, so now that we have this, we need to draw the rectangle for our reading. So first we have to change the brush. Remember, we had set the brush, the track brush. Now we are now drawing the reading. We need to set the brush to the reading brush. Okay, it's reading brush here. Okay, so the next thing that we need to do is to draw the reading. So the way we are going to do that, we are going to use 3 points. We're going to use 3 points. So if you let me just show you where I'm getting it. So if we go to Q to draw it, we need to see these methods for this. So you see this in the documentation. So we have this method that we're going to be using to draw the rectangle. It's the same method that we have used here to draw the rectangle. So if you see, it takes in a QRect, right? So here we just put the bounding rectangle, right? But we are going to do it a bit different here. So we need to check how we can, the ways we can construct a Q rectangle. So we have these constructors, right? You see, this one takes the x coordinate, the y, and the width and the height, and we have this one take the Q point and the size, and we have this one. This one is the one we are going to be using. So it takes a top left, Q point top left, and then a bottom right. So this is what we're going to be doing. So first we need to create these 2 points, right? So Q point, right, left point. Okay, so our top left point is going, remember that our x coordinate is similar to our bounding rectangle dot x. It's similar, it's the same x coordinate, but the y coordinate is different. So our y coordinate for the top left now is going to be this inverted height that we have calculated here, right? So we now go to the second one, that is the bottom left coordinate. Right? So bottom left coordinate, remember the bottom left coordinate is going to be the bottom left. Let's comment this and let me show you if I run this so that you can see what I mean. Okay, it's running. Okay, it's building effect running now. Alright, so this is our gauge. So we are going to have inside here, we are going to have our reading, right? So this point, this top left point it will be somewhere here, right? And then the bottom right is this one. So you can see the bottom right is just the same as the bounding rectangle dot width and the bounding rectangle dot height. So that's what we're going to put here. So bounding rectangle dot width, bounding rectangle dot height. Alright, so we have our points. Now what we need is a Q rectangle. Just put this in place when we paint our writing. So let's just paint it. Paint, draw rect, right? Q rect left coordinate left. Here we go. So this should draw our reading, right? Okay, so if we run this now. Let's see. It's building. Right, there we go. There we go. So this is how our gauge is going to be looking. So if you look at this now, what we have done is let's go scroll to the top and just walk through the steps that we've done. All right, so here we specified this bounding rectangle, right? So this bounding rectangle, remember, QQuickPaintedItem provides us with this bounding reg. So this bounding reg is determined by the width and height that we're going to specify in QML, right? We've done this. So this bounding rectangle is going to be this one. This is our bounding rectangle, right? So we've created our linear gradients, which we're going to use to paint, which we've used actually. Okay, so now the gradient for the track is the one that is in the background here, right? So the gradient for the reading is this one. All right, so we have created our brushes, right? Our track brush and our reading brush. Then global settings, we set render in, so this is to smoothen the edges, right? If we remove this, you see that there will be some jagged corners here. So to smoothen up things, we have to set the anti-aliasing. All right, then we didn't want to draw the borders right here. So if you don't set the QT pen to no pen, you will see a 1 pixel border around these rectangles. That will not be nice. So that is the reason why we did this. Okay, so we have set our clip path. So this clip path, it's a rounded rectangle that is clipping our components here. All right, so our rectangles, in fact, what we've drawn inside here. So we could have used we could have drawn a rounded rect for this track, but now if we do a rounded rect for this inner reading right here, we would see a roundedness in here, and it would our UI wouldn't look nice. We wanted this reading to be just flat here at the top. So that is why I had to go with the clipping, right? Okay, so our track, we set the brush for the track and then draw the track. Then here we calculated, we inverted the height so that we can calculate the exact height that we need, starting from the bottom and going upwards. So this is the inverted height. So here you've drawn the reading here. So basically this was the goal for this section, to show you how you can make a component from C++ and then import it and use it in QML. Okay, that's it for now. So in the next section we are going to see how we can create our sensor. So we're going to create a sensor object that we are going to put some dummy. You are going to randomize some sensor readings and see how it affects as the readings change. Okay, so that's it for today. Thank you for your time, and see you in the next section. Bye.